Yes, good morning. Good morning, one and all. So, in the last class, we discussed about the trigonometric identities, right? So, based on the trigonometric identity, we worked out example problems. So, once can we recall the trigonometric identities fast? Yes, who is going to tell that trigonometric identities? Anurag. What is the first identity, Anurag? Anurag. Hello, Anurag. First identity. Can you tell me the first identity, Anurag? Yes, first trigonometric identities. Anurag. So yesterday we learned actually trigonometric identities right now. So what are the trigonometric identities? Tell me fast. Yes, Anvit. Anvit. Hello, Anvit. Yes, which is the first one, Anvit? Anvit. Which is the first identity? Yeah, Arun.
Yes, Mataji.
Arun, yes. Which is the first identity, Arun?
Cos square A plus sin square A is equal to 1.
Yeah, sine square theta plus cos square theta, which is equal to 1. Very good. Next, second identity, Ashwet. Ashwet. Ashwet.
1 plus tan square
1 plus tan square theta is equal to
x square 0
sec square.
x square theta sorry
Sec square theta. You are telling 0. Okay, sec square theta. Okay, so next, who is going to tell the third one? Third identity. Yes, Bhuwana. Bhuwana. So, Bhuwana. Hello, Bhuwana. Darshan Hegde. Darshan Hegde. Darshan. Hello. Darshan. Yes, Karthik Gowda. Karthik Gowda. Third identity.
Cot square A plus 1 cos x square A.
1 plus 1
Cot
plus
square
cot square theta is equal to
cos x square theta.
yes, cosec square theta. So these are the three identities which we derived in the last class, right? See, first identity is sin square theta plus cos square theta is equal to 1. Second is 1 plus tan square theta is equal to secant square theta. Third one, 1 plus cot square theta is equal to cosec square theta. So yesterday we have worked out few problems related to this also. So today we are going to discuss the exercise part. That is the fourth exercise of the trigonometry chapter. That is the last exercise. So let us discuss the last exercise now. Okay. So we have the solution here. We'll discuss the first four problems with the help of this solution. Then later for fifth problem. So in the fifth main, again 10 sub questions are there. Very important questions that we will explain on the board. Okay. So now the first four questions we'll discuss with the help of this page. Okay. See here. We have exercise 11.4 solution. Okay. See, 1 second. I'll check the recording version. Yeah, recording version. Okay. Express the trigonometric ratios sin A, sec A and tan A in terms of cot A. So the first question is express the trigonometric ratios sin A, secant A and tan A in terms of cot A we have to express. Yesterday we discussed this type of problem, right? Okay, sin A. First we'll start with sin A. Sin A in terms of cot A we have to express. But we know that sine is nothing but 1 by cosec A. Correct, no? Yes, 1 by cosec A we know. Sine A relationship is 1 by cosec A. Then we know that one identity, that is 1 plus cot square A. Here we have third identity. So 1 plus cot square A is equal to cosec square A. Then sin square A is equal to 1 divided by, here in place of cosec A, can we transfer this 1 plus cot square A? How can we transfer this 1 plus cot square A? Because sin A is 1 by cosec A, then sin square A is 1 by 1 plus cot square A. Is that clear? Or cosec square A first step. Then cosec square A value is 1 plus cot square A. Then we need sin square, actually sin A. Here we have sin square A is equal to 1 by 1 plus cot square A. What is the value of sin A? Sin A is 1 divided by square root of this power 2 transfer to this side, square root of 1 plus cot square A. Got the idea of this problem, students? Yes, 1 second, 2 students are waiting. Okay, yes. See, now you just observe this one. Got the idea now? Sin A, which is equal to 1 by cosec A. So here we are going to use the formula 1 plus cot square A is equal to cosec square A. So first we have to write sin square A. Sin square A is 1 by cosec square A. Then sin A is equal to 1 divided by 1 plus cot square A. Okay, now second one is secant A. So we have to express this secant A in terms of cot A. So now secant A, how to write that secant A? So cot A is cosec A divided by secant A, right? Cot A, which is equal to, see here, actually secant A we have to express in terms of cot A. So secant A, which is equal to cosec divided by cot. So why we have to take this one, cosec divided by cot? Can you give the explanation for this? Why we have to write secant A is equal to cosec A divided by cot A? So who is going to tell this one? Cot A is equal to cosec A divided by secant A. So really, cot A is cosec A divided by secant A? Yes, of course. When we consider the ratio of this cosec A and secant A, we'll get cot A answer only. So cot A is the ratio of cosec A and secant A. Then how can we write secant A? Just transfer this secant A to this LHS side. Take this cot A to this side. Then what answer you will get? Secant A is equal to cosec A divided by cot A. See, while solving this exercise, you have to be think. Okay, so what relationship we have to take here? We took relationship that cot A is cosec by sec also. Okay, then secant A is cosec by cot A. So now secant A is equal to cosec A divided by cot A. Cosecant A we can write it as 1 by sin A. Then cot A as it is only, because secant A we have to convert at cot A only. So next, see here, so 1 by sin A, that whole divided by cot A. So how can we write in the next step actually? So 1 divided by 1 plus cot square A. What we did actually here, 1 we took constant sin A. Just observe the first answer. Sin A is 1 divided by square root of 1 plus cot square A. Got the idea, no? In place of sin A, we have to substitute the above answer, that is 1 divided by square root of 1 plus cot square A, that whole divided by cot A. So that is equal to 1 into, when we took the reciprocal, 1 into square root of 1 plus cot square A divided by cot A. 1 into anything is that 1 plus cot square A only. So 1 plus cot square A divided by cot A. So this secant A is converted in terms of cot A. Got the idea of this problem, students? See, we have to take the relationship first, cosec by sec, then sec is equal to cosec by cot, then cosec is 1 by sin A, cot as it is 1 by sin A. In place of sin A we have to substitute the first result, so then you will get the cot form. Is that clear? So this is about the first main second question. 1 second, 2 students are waiting. Okay, yes, we'll continue. So this is a little bit different problem. See, we have to work out it properly. So then tan A in terms of cot A we have to convert. Very simple. No need to convert. Tan A is nothing but reciprocal of cot A. So it is direct. Therefore tan A is equal to 1 by cot A. Is that clear, students? Tan A which is equal to 1 by cot A. Very simple question this one. Yeah, this is about the first main. Okay. Now we'll discuss with the second main question. Second main question is write all other trigonometric ratios of angle A in terms of secant A. Okay, here the question is all other trigonometric ratio of angle A in terms of secant A. So we have to write all the ratios, trigonometric ratio in terms of secant. So in the sense secant is the answer. Secant barbeku. Okay. So first we know that cos A. Cos A in terms of secant A, it is very easy because cos A is 1 by sec A. Okay, cos A which is equal to 1 by secant A. With the help of this one, we can move further with the different ratio. Cos A is 1 by secant A and we know one identity that cos square A plus sin square A is equal to 1. So cos square theta plus sin square theta is equal to 1. So when we convert this into sine form, sin square A is equal to 1 minus cos square now. When we transfer this cos square to this side, then sin square A is equal to 1 minus cos square A. Then sin square A is equal to 1 minus cos A result is 1 by secant A. Can we substitute this cos square A as 1 by secant square A? Yes. Then sin square A is equal to, by taking the LCM method, secant square A minus 1 divided by secant square A. Then sin square A is this one. We need the sin value. Sin A is equal to square root of secant square A minus 1 divided by square root of secant square A. Then here in the denominator only we can remove this square and square root. So then numerator it is a binomial terms. Therefore, so square root of secant square A minus 1 is as it is. Then secant square A and here square root get cancelled. Answer is secant A. So sin A in terms of secant form is square root of secant square A minus 1 divided by secant A. Got the idea of this problem now? So, okay, next, this sine function is over, cos function is over. Next, tan we have to convert in terms of secant. So, we have the relationship, very simple. 1 plus tan square A is equal to secant square A. Second identity we have. Then tan square A is secant square A minus 1. Then tan A is equal to square root of secant square A minus 1. This is very simple actually because we have the direct identity to convert the tan into secant form. So 1 plus tan square A is equal to secant square A. Therefore tan square A is equal to secant square A minus 1. Then tan A is equal to square root of secant square A minus 1. This is the answer. Now, so first three answer we got cos, sine and tan. If we got this one, then it is very simple to write cosec, sec and cot because this is the reciprocal part. Okay, cosec A which is equal to 1 by sine A. So divide 1 divided by sine A answer already we got. Sine A is square root of secant square A minus 1 divided by sec A. Just to substitute that one. Then in the next reciprocal step, that secant A divided by secant square A minus 1. Okay. So this is about the cosec A. Problem is not over. Still secant A and cot is remaining. Now you just observe cot A which is equal to 1 by tan A. Cot A relationship we know 1 by tan A. So therefore cot A is equal to 1 divided by tan A. Answer is actually root of secant square A minus 1. No, tan form you just remember in the last page, you just observe that this page tan A is equal to square root of secant square A minus 1. No, that you have to substitute in here. Cot A is 1 by tan A, then 1 by square root of secant square A minus 1. Is that clear, students? So this is about the problem. And secant square, why we are leaving secant square? So the problem is only we have to express the trigonometric in terms of secant A. So secant A is already in the form of secant A only. So that's why. So this is the end of the problem. Now the third question is very simple. For the third question we have to use the trigonometric ratios of complementary angles topic. See, the question is evaluate sine square 63 degree plus sine square 27 degree. that divided by cos square 17 degree plus cos square 73 degree. Okay, sin square 63 degree plus sin square 27 degree divided by cos square 17 degree plus cos square 73 degree. So now first sin 63, just forget about this square. Okay, later we'll apply that one. Sin 63. How can we write sin 63? Sin A is equal to cos of 90 minus A, no? So therefore sin 63 is cos of 90 minus 63. Then sin 63 is cos 27. Yes, if sin 63 is cos 27, sin square 63 is equal to cos square 27. We can write this type also. Sin square 63 is equal to cos square 27. Now, let us take this cos square theta is equal to sin square 90 minus theta. So, can we write the expression like this? Yes, we can write, because cos theta is equal to sin of 90 minus theta, in the sense cos square theta is equal to sin square 90 minus theta. Then cos square 73, we are taking this cos square 73. Cos square 73 is sin square 90 minus 73. Then cos square 73 is sin square 17. So now take the ratio here. Sin 63, sin square 63 we got cos square 27. Substitute that one. Sin 63 is replaced as cos square 27. We are keeping this sin square 27 as it is, as sin square 27 only. Okay, now in the denominator, cos square 17 already, cos square 17 only. Plus cos square 73, cos square 73 we converted as sin square 17. Okay, so here cos square 17 degree plus sin square 17 degree. 17 degree. Are you observing one identity here? Cos square theta plus sin square theta. So to apply this cos square theta plus sin square theta, we need that theta common. 27, 27. Here 17, 17. So we can apply this cos square theta plus sin square theta is equal to 1 formula, no? Yes, cos square theta plus sin square theta is 1 divided by, here also cos square theta plus sin square theta, which is equal to 1. Is that clear, students? This is a very simple question actually. Evaluate. So this is about the problem. Here we took the help of trigonometric ratios of complementary angles topic. Okay, so we'll move to the next question now. Here in the third question, again one more question is there. Okay, sin 25 degree into cos 65 degree plus cos 25 degree into sin 65 degree. So this is the problem. So now again same to same trick we have to apply. Sin 25. You take sin 25. Express in term of cos. Sin 25 is equal to cos of 90 minus 25. Then sin 25 is equal to cos 65. Sin 25 which matches with cos 65. Okay. You keep this cos 65 as it is. Now you take with the cos 25. Cos 25, if we express in terms of sine, then sine of 90 minus 25. Then cos 25 is equal to sine 65. Got the idea now? Sine 25 is cos 65. Cos 25 is sine 65. Now you have to substitute. We are keeping this and this constant. Is that clear? Now sine 25 value is cos 65 into cos 65 is cos 65 only plus cos 25 value is sin 65 into sin 65 value is sin 65 only we are keeping. So now cos 65 into cos 65, cos square 65 plus sin 65 into sin 65, sin square 65. Then cos square 65 plus sin square 65 is equal to 1. Answer is 1 because the identity cos square theta plus sin square theta which is equal to 1. Is that clear, students? Yes, this is about the second problem. See here, while solving the problem you have to think which one we have to take and which one we have to maintain constant. So that is your part. You have to work out that one. You have to think that one. Okay, so now we'll move on to the fourth main. The fourth main are multiple choice question, but we cannot take it lightly. Oh, it's okay, multiple choice question. For that multiple choice question also we have to work out the problems and we have to choose the one right option. Okay, so now let us discuss the fourth problem. Choose the correct answer. Choose the correct answer. First one. 9 secant square A minus 9 tan square A is equal to dash. Okay, 9 secant square A minus 9 tan square A is equal to dash. Options are 1, 9, 8, 0. So we have to work out actually this one. Actually what we know, tan square A plus 1 is equal to secant square A. We have the identity, second identity, right? Tan square A plus 1 is equal to secant square A. Okay. So 1 is equal to secant square A minus tan square A. When tan square A comes to this side, then it becomes minus tan square A. Now, are you observing here secant square A, tan square A? Here also secant square A, tan square A. What we can do, we can take 9 as a common factor. No, just remove that 9 as common factor. Then inside is secant square A minus tan square A, which is equal to 9 into. What is the result of this one? Secant square A minus tan square A result is always equal to 1 because we have the identity tan square A plus 1 is equal to secant square A. So 9 into 1 is 9. So the right answer is option B. Got the idea of this problem, students? Yes, option B is the right answer. Is that clear, students? Yes. So let us work out the second multiple choice question now. Multiple choice questions are simple only. Now this is the second multiple choice question, little bit lengthy. Okay, the question is like this. 1 plus tan theta plus secant theta into 1 plus cot theta minus cosec theta. Okay, which is equal to dash. 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta is equal to dash. Options are 0, 1, 2, minus 1. Options are 0, 1, 2, minus 1. Is that clear? Okay. So here the answer, how to write this one first? Actually, we have to apply some relationships here. 1 plus tan theta, yes, of course it is sine by cos, plus sec theta is 1 by cos theta, into 1 plus cot theta, we can write it as cos theta by sine theta, minus cosec theta, we can write it as 1 by sine theta. Okay, next step. So here only keep this 1 plus cos theta as it is. Add these two, 1 plus sine theta by cos theta. Then here it is 1 actually. What is the LCM now? Cos theta is LCM. Then cos theta plus sine theta. Plus 1 by cos theta as it is. Here also we have to add these two. That is sine theta is denominator. Then sine theta plus cos theta divided by sine theta minus 1 by sine theta. Okay, now we have to add these two. This one and this one. Absorb the same denominator. Then cos theta in the denominator. So what we have to do? We have to add the numerator. That is cos theta plus sine theta plus 1. Here also sine theta, same denominator. Then sine theta in the denominator. So just we have to take this one as it is. Sine theta plus cos theta minus 1. Okay. So now group these two. Cos theta, sine theta one group. Sine theta, cos theta. So what we can observe here is cos theta plus sine theta into cos theta plus sine theta whole square. No? Yes, whole square in the sense a plus b whole square formula. Can we apply a plus b whole square here? Then a square sine square theta plus b square cos square theta plus 2ab, 2 into cos theta into sine theta. Then plus 1 into minus 1 is minus 1. That divided by here denominator to denominator multiplication cos theta into sine theta. Okay, that is sine theta into cos theta. Next, here you just observe sine square theta plus cos square theta. We have one identity. Substitute identity as 1 plus 2 into cos theta into sine theta as it is minus 1 divided by sine theta into cos theta. See here in the numerator cos theta into sine theta and in the denominator also sine theta into cos theta we can cancel and plus 1 minus 1 we can cancel. Then answer is plus 2. So the right option is option C. Got the idea of this problem, no, student? First step you have to be very pakka. So what relationship we have to take? So then just add these two. Okay, then add these two. Okay, we'll get cos theta plus sine theta plus cos theta. Take that as one group. Then plus 1 into minus 1, keep it separately. Just multiplication like this. Okay, so then answer is 2. Got the idea of this problem, students? Yes. One second. Okay. Yes. So we'll go to the next question now. Third problem. Third multiple choice question. Yes. Secant A plus tan A into 1 minus sin A is equal to dash. Secant A plus tan A into 1 minus sin A is equal to dash. Options are secant A, sin A, cosec A, cos A. We have to think which one is right answer. So for that, secant A 1 by cos A plus tan A sin A by cos A into 1 minus sin A as it is. Then here cos A same. Okay. Then add the numerator 1 plus sin A into 1 minus sin A. A plus B into A minus B. Can we apply that identity actually? A plus B into A minus B. Here in the denominator 1 is there. A square minus B square. 1 square is 1 only. Minus B square is sin square A divided by cos A into 1 is cos A only. Then 1 minus sin square A. Here we can apply one identity because sin square A plus cos square A is equal to 1. Then what is the result of 1 minus sin square A? 1 minus sin square A is cos square A. Now 1 minus sin square A we can substitute as cos square A. Cos square A divided by cos A. Then cos square A divided by cos A. Here cos square A in the sense here 1 cos A and 1 cos A get cancelled. In the numerator 1 cos A is remaining. So answer is cos A, that is option D. Option D is the right answer for this question. Actually this question is very simple question. Is that clear? Yes. Now we'll move to the last multiple choice question. That is 1 plus tan square A. 1 plus tan square A divided by 1 plus cot square A. 1 plus tan square A divided by 1 plus cot square A. See, by looking this one only we can identify that third identity, right? 1 plus tan square A is secant square A. Then here 1 plus cot square A is, that is third identity, right? This is second identity. 1 plus cot square A value is secant square A. Secant by cosecant. Secant A by cosecant A. That is hypotenuse by adjacent divided by hypotenuse by opposite. See here. First class you have to recall. Secant A is the ratio of hypotenuse by adjacent. Cosecant A is the ratio of hypotenuse by opposite. If you take the reciprocal, hypotenuse by adjacent into opposite by hypotenuse. Hypotenuse get cancelled. Therefore, opposite by adjacent is remaining. So, opposite by adjacent is the ratio of which function? That is tan A function. So that secant A divided by cosecant A, we can write as tan A. See here, you have the clarification for this. How secant A divided by cosecant A is tan A? According to this relationship. Okay. So therefore, secant square A, cosecant square A, what happens then? Tan square A. So option D is the right answer for that question. Option D is the right answer for that question. Is that clear, students? This is about the first 4 problem solutions. So just now we finished actually multiple choice question. Is that clear, students? Yes. So can we move to the next main, 5th main question? Yes, that we have to work out on the board. Okay. So wait for a minute.